Good afternoon, everybody. Our today's topic is estimation of calcium ions of the soil by using complexometric titration. So, first of all, I'm discussing the principle of estimation of calcium ions in the soil. The amount of calcium ions present in the soil can be determined by titrating it against, or it here means solution of soil, by titrating soil solution against standard solution of EDTA. And standard solution of EDTA means any solution of EDTA whose strength, or I can say normality or molarity, is known. Standard means whose concentration is known. So in order to determine the strength of calcium ions present in the soil, we need to take standard solution of EDTA. And in this titration, muroxide indicator is used and pH of the solution is kept alkaline. And for this, a few drops of muroxide indicator is added to the soil solution containing calcium ions to form calcium indicator complex. This metal indicator solution is then titrated against standard solution of EDTA, which is taken in the burette. Now what happens when we add muroxide to the calcium ion solution, or you can say soil solution having calcium ions, then muroxide forms a calcium indicator complex, and upon adding EDTA, EDTA replaces the muroxide from the calcium indicator complex to form calcium EDTA complex. And during this, the muroxide indicator is set free, and free muroxide is having purple color. This gives the endpoint, means endpoint obtained is red to purple. And this equation shows that calcium ions present in the soil react with indicator muroxide to form calcium indicator complex. Now this calcium indicator complex then reacts with EDTA. EDTA here I have represented by H2Y2 negative, means we are using diasodium salt of EDTA. So when diasodium salt of EDTA from the burette is added to calcium indicator complex, then EDTA replaces indicator muroxide from the calcium ions and form calcium EDTA complex, and muroxide is set free. So please note here that calcium indicator complex is having red color, and when EDTA replaces indicator from the calcium, muroxide is set free, and or it becomes free, which is having purple color. So that's why we get endpoint from red to purple, because calcium indicator complex in this case is red and the free indicator is having purple color. So endpoint is red to purple. And please note here that in this equation, when I am reacting calcium indicator complex with diasodium salt of EDTA, it is forming CaY2 negative complex, which is calcium EDTA complex. So in this case, one molecule of, or I can say that one molecule of calcium combines with one molecule of EDTA. So I can say that in the complex their molar ratio is 1:1. This point is important, mean they combine in 1:1 molar ratio. Now next is our requirement. What do we require? So first is reagents. So for the determination of the calcium content of the soil, we need standard solution of EDTA. Now I told you standard mean any solution whose molarity is known. Suppose it is 0.01 molar. We can use solution of other molarities also, but it should be known, like 0.1. And then we require 1 molar NaOH solution, and whose pH is about 12, and we require muroxide indicator 40% ethanol, 1 molar ammonium acetate solution. So these are different reagents that we require, and the apparatus that we need are burette, pipette and titration flask and burette stand, all these for titration purpose, and beakers also. So first, now in order to determine the calcium content of the soil, the procedure can be divided into two parts. First is processing of the soil or preparation of soil extract, and second is titration. So in the first part, preparation of the soil extract, we need to take 50 grams, or I can say known weight of the soil. Suppose I am taking 50 grams of dry soil, and then we need to dissolve it in 100 ml of ethanol in a conical flask. So what we will do, we will take 50 grams of dry soil in a conical flask, and we will add 100 ml of 40% ethanol to it. Then we will shake the contents thoroughly to dissolve most of the part, and then we will allow the suspension to stand for 10 minutes, and after that filter the suspension by using Whatman filter paper and wash the soil residue, that is which is obtained on the Whatman filter paper 2-3 times by using 40% ethanol. Then collect the filtrate in a beaker. Then transfer the soil residue into another beaker. Residue here means which is left on the Whatman filter paper, and to that we will add 100 ml of 1 molar ammonium acetate solution. Now why 1 molar ammonium acetate solution is added? 1 molar ammonium acetate solution will react with the soil and it will release the calcium ions or extract the calcium ions from the soil in exchange for ammonium. So purpose of ammonium acetate is that it will free the calcium ions from the soil so as to get them into the solution. Then shake the contents well and leave it undisturbed for overnight. Then after keeping it overnight, filter the contents by using Whatman filter paper fixed on a Buchner funnel and collect the filtrate. So now I am having two types of filtrate, one which I obtained by dissolving the soil in ethanol, 40% ethanol, and second obtained after treatment with ammonium acetate. Then we will mix both the filtrates and note the total volume of the extract. Means suppose we are making a known volume like 200 ml, 250 ml, 500 ml. You can make any volume, but the purpose is that your volume should be known, and that is usually made in a measuring flask. Then after making the known volume of the given weight of the soil, second step is titration. So for titration, what we will do, we will take a burette and we will rinse it with the EDTA solution and we'll fill it with standard solution of EDTA and pipette out, and we'll pipette out 20 ml of soil extract solution in a titration flask. Then add 2 ml of 1 molar sodium hydroxide solution and 3-4 drops of muroxide indicator to the titration flask. When we will add muroxide to the soil solution containing calcium or soil extract, red color will appear. Then we will note the initial reading of the burette and we will start titrating the soil extract solution containing muroxide indicator against standard solution of EDTA from the burette till the color of the solution changes from red to purple. When color of the solution becomes red by adding single drop of the EDTA solution, that will be our endpoint. Red to purple will be our endpoint, and we will note the final reading of the burette at this point. So then the difference of the final reading and the initial reading will give the volume of EDTA solution used for given volume of soil extract. Next are the calculations or general calculation. Suppose we used 20 ml of soil extract for each titration. Then I can say that volume of EDTA solution used for 20 ml of soil extract will be equal to VML, say. Now, as I told you that as calcium forms 1:1 complex with EDTA, therefore I can say that number of moles of calcium ions present in the solution would be equal to the number of moles of EDTA consumed. We need to use this generalization because in this equation calcium forms or calcium reacts with EDTA in 1:1 molar ratio. So I can say that number of moles of calcium present in the solution would be equal to the number of moles of EDTA consumed. So I can say that if I am having 1 mole of EDTA, then it would be equal to 1 mole of calcium ions. So similarly I can say that if we are using 0.1 moles of EDTA, then it would be equal to 0.1 moles of calcium ions. So now by using this generalization we will do our calculations. Now 1 mole of calcium, if we are having, we know the number of moles of EDTA consumed, that we can determine by using the volume used for titration. So 1 mole of calcium contains 40 grams of calcium ions. So 0.1 mole of calcium ion will be equal to 4 grams of calcium ions. Now by using this generalization we can say that number of milligrams of calcium ions equivalent to 1 ml of EDTA is equal to X milligrams. Now we are just representing these in milligrams. So if number of milligrams of calcium ions equivalent to 1 ml of EDTA is equal to X milligrams, then number of milligrams of calcium ions equal to V ml of EDTA. If 1 ml of EDTA is equal to X milligrams, then I can say that number of milligrams of calcium ions equal to V ml of EDTA will be equal to V into X milligrams, because if 1 ml of EDTA is equal to X milligrams, then V ml of EDTA will be equal to V into X milligrams. Now if we have used 20 ml of soil extract for titration, then 20 ml of the extract will contain, or I can say 20 ml is containing V into X milligrams because I used 20 ml. Therefore I can say that 1 ml will contain Vx by 20. So as we represent the strength in per liters, therefore 1000 ml contain calcium equal to Vx by 20 into 1000. So we will get the result in milligrams per ml, and let it comes out to be equal to A milligrams per liter. So this is how you can calculate the amount of calcium present in the soil. Thank you.